I'm going to talk, as Elliot mentioned, about problems posed by overabundant deer and invasive plants in forests in northern New Jersey. Before we get into that, it's important to recognize that the return of deer to our area and throughout much of the country is really the result of what is a conservation success story. That deer were nearly driven to extinction as a result of commercial hunting by the end of the 1800s. And it was really the hard work of generations of biologists and regulators and sportsmen that brought deer back to the levels that they should be in our forest, because they do belong as a vital part of our forest ecosystems. That recovery work had largely taken place by the 1970s with the return of deer throughout most areas that they historically occurred. But unfortunately, as a result of a number of other factors that have changed over the past 150 years, deer populations rose to really historically unprecedented levels in the time since then. And those factors primarily include the extermination of natural predators like wolves and cougars from our area in the 1800s, and the fragmentation of forest ecosystems by agriculture and residential subdivisions, which provided supplemental food resources for deer, more than was naturally available otherwise, as well as refuge from hunters, because it's difficult to hunt in suburban situations. So as a result, as you can see in the image on the right, by the late 1980s, the University of Georgia, which compiled this data, estimated that deer populations had exceeded 15 per square mile in yellow there and over 30 per square mile in red throughout much of their natural range, including most of this area. Research by the US Forest Service has consequently found that deer browse is a major problem throughout large areas of the continent, with the mid-Atlantic region suffering the greatest impacts from deer browse. Nearly 80% of our forests are experiencing moderate to high levels of browse, which closely corresponds to the levels of deer that are in these areas. Historically, it's thought that deer populations occurred at approximately 8 to 11 per square mile on average. And whether or not those are accurate for any particular area, we know that when deer exceed those levels, they can become problematic in a number of ways. The first thing that tends to happen is when deer populations rise above 10 per square mile, the species that they like to eat the most in the forest begin to decline. So it's trillium, lilies, hemlock, dogwood, the most palatable species start to suffer from those impacts. When you exceed 15 per square mile, research from the US Forest Service has found that tree regeneration begins to decline. And when you get over 20 deer per square mile, all sorts of things begin to shut down in the forest, from tree regeneration and understory conditions as a whole. Wildlife, including birds, amphibians, invertebrates, and many others, begin to suffer those impacts. And so the last time the deer populations were at those healthy levels of 10 per square mile in New Jersey were the early 1970s. And the image you see on the left is from the Rutgers Research Forest in central New Jersey at that time. And you can see the picture of a perfectly healthy forest with the wildflowers and ferns on the forest floor, healthy and diverse shrubs and young trees growing above them. Unfortunately, in the time since then, deer populations, as we've seen, have continued to increase. The last statewide estimates by the DEP found in 1999 that deer were an average of 38 per square mile statewide, with the lowest of 13 per square mile in the Pine Barrens and the highest of 76 per square mile or so in central New Jersey. And as a result of those elevated deer population densities, what we see typically in forests today are one of the two images on the right, where there's either nothing growing in the understory as a result of these deer browse impacts, or in that vacuum that the deer have created, invasive plant species fill that void and rise in abundance. But that data was about 20 years old at this point. And so we've been collecting data using infrared drones in the past 3 years and have covered over 100,000 acres across central and northern New Jersey. And we found that on average, deer populations are 70 per square mile across the entire northern part of the state, with the central region that had the highest deer densities historically, currently an average of 112 per square mile. So current deer densities in this part of the state are anywhere from 7 to 12 times the amount that we need deer to be at in order to support the wealth of biodiversity and other ecosystem services that our forests provide us. The other research that we've been conducting for the past 10 years is following up on Rutgers studies that were conducted in the mid-20th century. We're fortunate in New Jersey to have a wealth of historical data on forest conditions beginning in the 1940s and through the early 70s, when deer populations were much smaller. And so we compiled all the data that was available from that time period and then revisited as many of the sites as we could relocate where those studies were conducted. And what you see here are the end results of that research, at least in part, comparing past conditions in gray to present conditions at the same exact sites in green. And what you find are whichever component of the vegetation you're looking at, whether it's tree reproduction on the top row or woody shrubs vines, and the herbaceous flora, we see catastrophic declines in each of these components of our forest understories. And as problematic as this is for the plants themselves, it's equally problematic for the plant and animal species that depend on these conditions for their own survival. And that's been borne out by research from a variety of different studies conducted over the past 30 years. Some of the most conclusive research has come out of the Allegheny National Forest in Northwest Pennsylvania, where a variety of researchers found that these kinds of deer densities, the bottom x-axis that you see there, ends up at about 50 to 70 per square mile, which is comparable to deer densities in northern New Jersey today. When you get to those levels of deer densities, tree diversity tends to decline by about 60%. And the most severe impacts of that decline are faced by the insect herbivores that are the most specific in their foraging needs. They operate on chemical cues to decide what they want to eat or not. And so as particular tree species decline or disappear, there's no food at all for some of those caterpillar species. And so caterpillar density declines, and most of our forest birds are insectivorous, at least in some stage of their life cycle. And so you can see bird densities declining in those same places. Ecologists refer to this as cascade effects or ripple effects through the ecosystem from one stage of the food web to the next. And this also happens with regard to nesting habitat, in addition to food resources. So studies by Rutgers researchers in the research forest in central New Jersey found that bird populations have declined since the 1980s of all species of ground and shrub nesting forest birds that occurred there. You can see that every circle in this graph on the left indicates a bird species. Anything below the line indicates a species in decline. And 100% of those nesting low to the ground have declined since the 80s, and the majority of mid-story canopy nesters have declined as well. Much larger scale studies have been conducted since then. Similar results have been found throughout the entire state of Pennsylvania. This is a study that was conducted 2 years ago, showing more or less the same results with low nesting forest birds, whether they be intact mature forest birds or early successional birds, declining significantly, in this case since the 1990s. And a number of other studies have borne out more or less the same results continent-wide, and other studies have shown similar effects with other deer populations elsewhere in the world as well. This is, in a sense, a global phenomenon because we've been eradicating predators throughout the areas where humans are occupying the planet. Herbivores increase, and you see the same effects play out worldwide. The place where tree regeneration tends to occur at the greatest levels are primarily in light gaps, where the increased light levels increase the rates of tree growth. Regeneration can occur throughout the forest understory, but it's in the light gaps where you see it occur in the greatest densities and the fastest rates. However, when you have deer populations at these levels, in this case, illustrating 20 to 50 per square mile, you do get tree regeneration continuing to occur in the light gaps because the tree's growth can outpace the deer. The problem is that it's selective regeneration, where the species that are most preferred by deer don't actually regenerate because they're being browsed out by the deer. The species that are able to increase in their numbers are those that the deer prefer to eat the least, species like birches and their relatives like ironwood and hornbeam and several others. And so what you get is an altered trajectory of future forests because only certain species are able to successfully reproduce and survive. If you implement this as a strategy for increasing forest regeneration by thinning forests to increase light levels that are hitting the forest floor, this can be really counterproductive, not only for changing the trajectory of forest development and modifying species composition in the future, but you're also going to be exacerbating the problem of deer because you're going to be increasing foraging levels for deer, increasing deer populations, and at the same time, increasing light levels that can favor the growth of invasive plant species as well. So in the end, it can be counterproductive if that's used as a tool for forest management in these situations where deer populations are elevated. In New Jersey, we have much higher levels of deer also occurring elsewhere. And in those kinds of situations where deer are greater than 50 per square mile, you tend not to get any native regeneration at all. The deer are eating everything in the understory that they can. The species that are least preferred by deer as a food source are the invasive exotic species, which we'll be getting to in a little more detail in a minute. In light gaps like you see here, you have nothing but Japanese Aurelia growing up as the canopy dominant. Beneath that is Japanese wineberry or barberry, and on the forest floor is Japanese stiltgrass. And you see an utter transformation of the forest into an entirely exotic system that never had occurred in this area before at all. And again, if you're implementing this in large scales, you're also going to be increasing deer populations as a whole. The worst case scenarios where this can play out is when you have decreases in tree regeneration combining with other factors affecting forests that increase the mortality of canopy trees. We know, for example, that emerald ash borer and other invasive pests and diseases are wiping out our canopy trees wholesale in some places. And if you combine canopy mortality with the lack of regeneration in those understories, what you get are basically forest loss entirely, where you have nothing but invasive shrubs, vines, and other species replacing what used to be forest because the trees can't grow in those conditions with the elevated deer levels. These are some local examples from Bridgewater and Raritan, and I'm sure you can find other examples elsewhere. Recent studies from just last year found that similar results can play out if, again, you use this as a tool for forest management. So whether it's a seed tree harvest or a clear cutting that occurs, if you have elevated deer levels, you can alter the trajectory of forest conditions in the future because deer are going to be suppressing regeneration, and you can actually be preventing forests from occurring in those areas and altering the land cover entirely. Alternatively, or conversely, if you address deer problems in our unprotected forests, you can see on the top left there, seedling populations decreasing precipitously as deer levels increase to the densities we've been talking about. If you turn that on its head and remove deer from those areas by using deer exclosures or other tools, you can see that over time, seedling and tree regeneration levels return to their historic levels, the same kinds that were found in the mid-20th century, in as little as 5 to 10 years. And those levels of regeneration can occur even under a closed canopy and shaded conditions, because as Emil mentioned early in the study, or early in the presentation today, many forest tree species are perfectly adapted to growing under shade conditions. They just tend to grow a little bit slower than when under light. And all you need to do is go to Duke Farms to see this play out, where with the square mile deer exclosure that they installed there 15 to 20 years ago, every one of the forest patches in that forest has lush regeneration occurring in the understory, including under entirely closed canopy conditions. And as those understory conditions begin to recover, you start to see the other things fall back into place as well. A number of exclosure studies, including both the Allegheny National Forest and others in Virginia, have found that in long-term deer exclosures, you get bird populations returning and responding positively as well, including the most sensitive species that we talked about that are nesting in the ground and shrub layers. Unfortunately, exclosures aren't really a feasible strategy for attacking deer populations at the statewide or regional level that they're occurring, but we have other tools at our disposal as well, including hunting and other forms of deer management. So while exclosures have been able to return our tree regeneration levels to the same amount as occurred historically, you can see that organized hunting, or which was often referred to as management hunting, or other forms of professional hunting by means of sharpshooters can lead to substantial beneficial changes and increases in tree regeneration in those situations. However, hunting can't be assumed to work in all situations, given the severe levels of deer populations that we have in our forests today. In many cases, it's far too great for recreational hunting alone to actually make much of a dent in the populations to translate into sufficient amounts of regeneration as we need to occur. So you can't assume that hunting alone is necessarily going to work, but if you implement the proper incentives and harvest goals and scientific approaches to managing deer for these kinds of purposes, our data suggests that it can translate into substantial benefits for tree regeneration and forest recovery in all of these ways. It also can't be taken for granted that deer populations are okay in some parts of the state. As we've seen statewide, or at least in the northern parts of the state, deer populations average 70 per square mile. And that's true for the Kittatinny Ridge and the forested regions in the upper highlands above the glacial moraine as well. In those areas, deer populations are in fact lower on average, but they still are far higher than historically occurred or naturally would occur in those forests. And they're still having substantial effects in forest regeneration and the other kinds of impacts that we've talked about already. So you can't take for granted that deer are okay in some places. Surveys need to be conducted to confirm that deer populations are not going to interfere with forest restoration, management, or whatever kinds of approaches you're taking to manage forage conditions to improve them in the future. The same is true of the Pine Barrens. Historically, the lowest deer populations, and still is the case today, occurred throughout the coastal plain and the Pine Barrens of New Jersey. And in those places, we're seeing similar sorts of things play out with intense impacts to Atlantic white cedar regeneration in some of the swamps and bogs that are there, as well as to some of the preferred browse species like swamp pink, which is a lily and an evergreen. And studies have shown that more than 90% of the swamp pink populations in New Jersey are currently experiencing direct impacts of deer browse, even in these places where deer impacts are the lowest in the state. And the only places in many of these populations where swamp pink is able to thrive are in these what are called natural exclosures, where clusters of swamp pink are surrounded by deep, mucky waters that the deer, that are less accessible to deer. And the swamp pink that are on the banks of the streams or in the upland or more mainland areas adjacent to them are being browsed to the ground year after year, leading to their slow decline and eventual disappearance throughout the state. And this is a federally threatened species that is in our care here in New Jersey. In addition to tree regeneration and other impacts, these kinds of things can also translate into increased exotic invasive plant species. The northeastern corridor from Boston down to DC has some of the highest concentrations of exotic invasive plant species anywhere in the lower 48, with the only comparable places being the San Francisco Bay Area and the Los Angeles Basin. Our studies comparing past forest conditions to present, again, showed major declines in our native species of the shrubs, vines, and herbs. And at the same time as those declines occurred, we saw dramatic increases, 40-fold increases in the cases of shrubs, of invasive species in those same places over time. The problem is that they can lead to the same kinds of food web effects as we talked about with deer. So while invasive species do provide some potential benefit, berries for frugivorous birds, for example, to feed on, cover, and nesting habitat in some cases, again, the herbivores are the most impacted. Our insect herbivores in particular don't recognize them as food. And while our native trees and shrubs and wildflowers provide food resources for dozens and in some cases hundreds of native moth and butterfly caterpillars, for example, they're close relatives that are introduced from faraway places like the Zelkova or the false spirea, fail to support any or very few, more than just a few of our native moth and butterfly species. And so as these species begin to take over our forest understories, it essentially creates a food desert for these species, leading to those same kinds of cascade effects rippling through the food web. And that's been borne out through a number of studies. And one of the more recent ones came out of Connecticut, showing how Japanese barberry in particular can lead to these kinds of trophic cascades in the food webs of insects and other arthropods that feed on their leaves, the predators that feed on those insects, the leaves as they decompose, and so forth. Deer are a part of the story as well, again, because invasive species are the least palatable to deer. The fact that deer are eating our native species first gives the invasives a competitive advantage over our native species. And when you take the deer out of the equation in these long-term deer exposures, one of the nice things to see is that our native species in many cases can actually outcompete the invasives entirely on their own. So looking at some of these long-term deer exposures, we found that our native vines and herbs were actually able to turn the tides on the invasive species without any additional intervention from humans in directly removing invasives in those areas. The shrubs and some other components of the flora might be a different story, but this is a positive sign. And then yet another indication that deer are a part of this larger problem of invasive plant species rising to dominance in our forests. Deer aren't the only part of the story, however. Probably more important to explain the prevalence of invasive species in our forests are the history of agricultural activities that occurred in many of these forests. As Emil talked about earlier in the presentation, a huge area of our forests in central and northern New Jersey are now occurring in what previously was agricultural conditions. Those forests were abandoned for the most part in the 1920s and 30s and thereafter due to economic changes. And as forests return to these places, we've benefited from increased forest cover in the state as a whole. The problem is that that history of soil disturbance and degradation actually facilitates the colonization of invasive plant species. And so if you look at the old intact forests that Vermeule had identified in the late 1800s that have remained intact as older, mature forests since that time, on average, those forests are about 50-50 native and invasive species in the shrub and woody vines. The herbs are holding out a little bit better compared to the woody species. But if you look at the post-agricultural forests in the same vicinity, in some cases right next door, well, you find that, that invasive shrubs in particular are anywhere from 5 to 20 times as abundant as the native species in those areas. So they're wholly transformed and utterly different from the kinds of forest conditions that occurred here historically and that we need to support our biodiversity and our other ecosystem functions that we depend upon. So land use history really needs to be taken into account in assessing forest conditions and addressing priorities for restoration, especially given the scale at which this is occurring. This is the same Vermeule map that Emil showed you at the state level converted into a GIS layer, which was done by the Rutgers Remote Sensing Lab under Rick Lathrop. You compare that to present day forest conditions, and what you find are that approximately 40 to 50% of forests in this region of the state today are occurring in these post-agricultural soils and settings. And so we've got an enormous number of, or a more enormous area of forest lands, nearly 300,000 acres, or perhaps more if you extend the map farther south, that are comprised of these super abundant invasive species understories, where tree regeneration is lower due to competition, and wildlife can't be supported to the same degree because they don't provide the same foraging and other resources, not to mention the reduced benefits for our flora. So this is clearly one of the major priorities for forest restoration and stewardship into the future, and really needs to be taken into account at the policy level from the state all the way down to the local level. In addressing these kinds of invasive species problems at this scale is really daunting. There's only a handful of tools that are really useful at this scale. And unfortunately, some of them are either too expensive or too risky in terms of potential collateral damage that could be caused to other flora and fauna, which might result from the application of synthetic herbicides, for example, at this scale, or potential damage to soil conditions by the use of heavy machinery to knock these invasives back. Biological controls can be a really valuable strategy for addressing invasive species, but unfortunately, there are very few successful biological controls that are available for the dozens of invasive plants that are overrunning our forests at this point. One of the more promising tools for forest restoration and controlling invasive plants at this point is prescribed burning or fire, because fire is an endemic disturbance to these kinds of ecosystems, and many plant species are adapted to those disturbances. And on top of that, we know that Native Americans used burning extensively as a part of their agricultural and hunting activities for thousands of years. And in many ways, those activities are responsible for shaping the kinds of forest conditions that we see in many parts of the state today. So we've been conducting research for the past 3 years looking into the extent to which fire might be used as a tool in northern New Jersey to knock back these invasive plant species in the same way that it's being used in southern New Jersey and elsewhere as a tool for wildfire suppression for safety purposes. And what we found is that for many invasive plant species, fire seems to be really promising. For Japanese barberry in particular, as you can see on the right, if you compare places that are burned to unburned, Japanese barberry gets knocked back extensively by even just a single burn going through these forest understories, about 50% reduction, with subsequent burns reducing it even further. And other invasive species like multiflora rose and some of the honeysuckles and burning bush, for example, will be knocked back similarly well. Unfortunately, other invasive species are actually benefit from fire, just as many of our native species do. So Japanese wineberry, for example, Japanese stiltgrass, and others can actually increase in response to fire. So if fire is going to be used successfully to manage invasive species, it's really important to take stock of what the initial conditions are to see what plant species are dominant, and then decide whether fire makes sense as a tool for addressing those needs. The other problem with using fire is that, again, in this situation where we have elevated deer populations, it can actually also knock back native regeneration and healthy understory conditions in general. So if you look at many of the places that were burned in these old, intact, healthy forest conditions, like Voorhees State Park, for example, where there was fairly rich understory still intact despite relatively high levels of deer in the surrounding vicinity, those places that have been burned showed dramatic reductions in tree regeneration and understory conditions in general, even 3 or more years after those burns took place. So the image you see here on the right, the area on the left was burned 3 years ago, and you can see even after 3 years, there's very little regeneration that's occurring. The immediately adjacent area on the right was not burned. We studied that as a control, and you can see relatively healthy conditions there. So again, you need to take stock of conditions at the outset. If understories are relatively intact or high quality or healthy, fire might not be the best tool for attacking invasive species or stimulating regeneration. You might want to focus on deer management or other strategies for forest stewardship in those situations. And the bottom line is that we need to be using evidence of all these kinds to inform our management. So identifying the conditions of the forest, not just the trees, but all the components of our forest understories, including the tree regeneration that's occurring at smaller size scales than are often measured as part of our forest inventories. The US Forest Service has guidance for how to incorporate these sorts of regeneration concerns into your forest inventories and analyses. Using infrared survey techniques to monitor deer populations, or at least get an initial assessment of baseline conditions so you know what you have to work with and how much regeneration or other impacts you can expect to see. And then measuring the other relevant conditions and threats to our forests along those lines, like the history of land use, as we talked about, fragmentation, which are driving deer patterns in many parts of the state, and other factors that might be of relevant concern for understanding what are the important issues to address and whether or not different kinds of management approaches are likely to be successful or potentially likely to cause more harm. The important part of this is also collecting follow-up data to monitor and measure the effectiveness of what we're actually doing. On public lands especially, we should be accountable to our plans and determine whether or not what we're prescribing and actually doing to our forest is working to the forest benefit and achieving the goals that we're setting out to achieve. And the only way to determine that with any confidence is to collect data, ideally independently, to determine whether or not those goals are met and whether or not any unintended consequences might be playing out at the same time. And you can continue to revise those goals and the treatments depending on what the data shows. And this process of evidence-based management out west has been referred to as adaptive management. And I think it's a valuable strategy and approach that we should be considering for forest management in New Jersey in general. Beyond management, we should also be thinking outside the box about prevention. A lot of these issues are preventable. Our old forests that were present in the late 1800s, many of them have no protected status whatsoever throughout the state, including our own campus, for example. This is a map of our campus. You can see there's 2 old forest patches that Remuel identified in the late 1800s. They're still present in the 1930s. And unfortunately, in the early 2000s, prior to my arriving here at least, half of those forests were converted into parking lots and buildings. Since that time, we've been successful in convincing our campus to protect the remaining old forest tracts. We've installed deer exclosures, incorporated them into our educational practices for our students, and monitoring the success of those restoration efforts for forest recovery. So we need to identify these forest patches in our community and prioritize them for protection. They're really the highest quality forests in our area and the lowest hanging fruit for forest restoration that we should be beginning with. On top of that, the problem of exotic species is going to be a never-ending uphill battle if we don't address the problem of continuing introductions of new species that are forever occurring. If we don't, in the end up prohibiting the importing, sale, and planting of these species in our communities, we're going to just see new species being introduced into our forests and a never-ending front of species to face that we're not likely to be successful facing if we don't deal with more preventative measures down the road, as many other states have implemented or are in the process of considering. And those species that are beginning to show signs of invasiveness, we need to identify those populations and eradicate them as soon as possible before they begin to overrun our forests to the levels that some of the historically invasive species like barberry and multiflora rose have occurred at, so that they don't rise to those levels of abundance and become nearly impossible situations for us to eventually address. So that's all I have to share with you for today, and thank you very much for your interest.